My name is Robert Graham. I was going to co-present today with David Maynor, but we had a client that called us up about 4 a.m. this morning and has an emergency. So we had to decide who was going to be the one up at 4 a.m. dealing with the client and who's going to be presenting. My title is CEO, so I think we chose to have the correct decision. The talk we're going to do today is the Lazy Hacker's Guide. I forgot what TCB stands for. Taking care of business. The thing is that in our community, there's lots of stuff we know about. Like, we know in theory that it works, but no one's actually ever done it in practice. And I think a lot of people don't do these things because they already, in their mind, solved the problem, so why go about solving it? So this is two presentations in one. One of them, the first one, will be pulling zero-day signatures out of security products. Security vendors often include zero-day information that the public doesn't know about. They include the protection in their products. Well, with our standard reverse engineering skills, we can pull that information out with a lot less work than actually doing our own vulnerability research. So we're going to walk through a case study of that, where we pulled the ZDI information from the Tipping Point product. The second half of the presentation will be sniffing Wi-Fi connections. So right now I've got a little Wi-Fi sniffer going that's sniffing the Black Hat Wi-Fi, and we'll see afterward what pops up. Now we all know, of course, the danger of sniffing, but what this tool does is it sniffs the cookies and the URLs into a proxy server and overwrites your own browser cookies with the cookies it found. The upside of that is that I can hijack other people's email sessions. So if you've got a session open with Gmail, then I can hijack that session, then I'm logged into your Gmail. I don't know your password, I just have your cookies. We are Arata Security. We founded in 2006. We do outsourced research and development. We're a typical consulting firm, except that we've got a product that are hacker eye view assessments, where we take industry threats and write up reports for our clients based upon how hackers would look at it. CIOs often get their information from vendors. This is another source. So security can be complicated. There's buffer overflows, finding those things, a lot of acronyms. But hackers are lazy. We often take the path of least resistance. So what we're going to show here is a way of bypassing that. Dave has this nice little comic he pulled out. Okay, at least that size accurate. So it's Friday night. You don't have any date to the big dance, as Dave likes to put it. And you have no O-Day. And of course, you know the politics of our industry. We all love O-Day. I'm an old-timer since the 1980s. Where in college, we didn't call it O-Day back then, but it was all about finding exploits and having secrets. And impressing our friends with what secrets we had that no one else had. And, trying to impress a girl about, all our elite hacking skills. And, of course, that doesn't actually work. So our hacking stuff, we can go through a lot of work. We can learn about operating systems, various forms of assembly, reverse engineering techniques, analyzing crash dunks, reading hexadecimal, and all that sort of stuff. Or we can do something a lot simpler. Let other people do the heavy lifting for you. So there are lots of companies that do zero-day stuff. Tipping Point's an example, IBM, ISS, EI, etc. By the way, Dave and I come from IBM, or Internet Security Systems. So back in the old days, I founded a company, Network Ice, that was bought by ISS, which was recently bought by IBM. So one thing you should take into account here is that I'm a bit biased. But that shouldn't matter too much. So all these companies invest in zero-day research. For example, ISS had the X-Force, where X-Force was a bunch of engineers. They do lots of presentations here at Black Hat, so you guys should all know them. So it's cutting-edge research to stay ahead of the hackers. Tipping Point has the ZDI program, which is a program that buys from hackers zero-day information. So these companies want to use zero-day protection and their zero-day knowledge as a differentiator. That's why they sell, hey, buy our products, because we're one step ahead of the hacker. So they're trying to win the arms race. So instead of discovering our own O-Day, why not just take theirs? So when we look at these products, we find that they're not actually they're not too difficult to get into. For example, a lot of security tools, when you get right down to it, when they express the O day they're looking for, they just write a regular expression pattern. So all we have to go is look for that regular expression pattern in the system. So the one we're going to do in our target today is the zero-day initiative from Tipping Point. There's a lot of controversy around the zero-day initiative, like people saying, well, should companies buy zero-day and encourage hackers or all that stuff. And I don't really care much about that. But what I do care is that it's a source of zero-day. So it's something that I can go after. So here are some example of some of the ZDI rules that, as a hacker, there are rules in there, or signatures in there, that have this zero-day in the product, but yet during these timelines, they're not yet publicly available. There's no patch for it or anything like that. So when you have a Tipping Point product, or any vendor's product really, they give you regular updates, and they usually just send you a file. They have usually most all these companies have an account. You log in, you download every few days there's a new update, and you get them. So if you want zero-day, you know it's in that file. So you have a nice little file on your desk. You know there's zero-day in it. And you want to find it. So so what you do is you load the file in your hex editor. It's kind of annoying. And you look for it. And what we find here is, obviously this is encrypted. There's some structure information at the very start of this file, but everything down below is obviously random data, therefore encrypted. So we look at some stuff. Okay, there's a magic sequence at the beginning. It's TPPA. Okay, that's Tipping Point something or other. But then there's some nice structured data. Then there's one interesting thing is payload data. So what we're looking for is, okay, we want to encrypt the payload or decrypt the payload. The next step is, okay, we got the file. We don't know how to reverse engineer it, so what we want now is code. We want to look at the code that's going to decrypt that file. So in our case, we went to eBay, bought a box, got it. This was a Unity 1 400. It was their 400 megabit box. That was $2,000. We grabbed the hardware. We pull open the case. They have a nice little network processor that sits on top, and then a little motherboard, typical PC motherboard underneath, and of course a disk drive. Actually, I wanted to bring the box here. I actually sent it via FedEx to the hotel, and it's now lost in the ether somewhere. But suspecting that might happen, I did actually bring the hard drive. So this is the hard drive that we pulled out of the box. It's just it's a 3.5-inch thing. They actually use a lot of boxes these days. Network equipment use notebook hard drives because they're more shock resistant. People drop network equipment a lot. So this is the thing. So all I have to do is just plug it into my PC and read it. So what it is, it's an ext2 file system. And I just look in the boot directory, and there's a number of stuff. Before we get to the code, I wanted to point out that there's this log file. And when the product runs, and this is pretty much the same with every product we've seen, they have log files. And the log files are very helpful. They're supposed to be helpful because they're supposed to help the customer support debug what's going on. So here we find there's a log file message there that says extracting payload into opt update sec and package information. That's a nice little string. So what I want to do is, okay, that's a printf string. So I want to look now in the binary. So the binary is VxWorks. VxWorks is a little bit tougher for IDAPRO. By the way, how many people here use IDAPRO? Number of people. So this is the standard reverse engineering tool that hackers use. So I've got the image, I've got the software. It's VxWorks software. I found it in the file system. I load it in IDAPRO. I start IDAPRO doing the analysis. I go away for coffee. I come back and it's 1% done. So I go to bed for the night, wake up in the morning, it's 45% done. It's a 10 megabyte image, but it takes IDAPRO about 2 days to do its initial analysis of it. And it produces a 150 megabyte dump. And it's not correct at the end of it. IDAPRO doesn't understand VxWorks all that much. So then what we had to do was write scripts that would go through and clean up the image to something that hackers can use. For example, have to rebase the image and stuff. So here's the example script that we use to clean up all the stuff. So then, now I find the string, extracting the payload. Okay. That's the next presentation. So I go through, I do my reverse engineering, and I find in the code where that string is used. So underneath that string, so near the top of that hex, that code there, you see where the string is. A little bit down later, you see package payload I don't know if I can point to it very easily. I don't think I can. Package payload extract in the middle of the screen. Okay, that's where the thing is decrypted. So all I need to do is reverse engineer that one function. It decrypts the package, and then I'm good to go. So that's fairly straightforward steps. It's what every hacker does in doing stuff. So the next step is with the hex editor program, is a nice little file structure thing. What we want to do is reverse engineer the code to see how it's interpreting it. So we refine the statements that look for that signature, and we find a number of interesting statements, interesting fields as we're reverse engineering the code. In this case, there's 3 interesting fields, one of which is the pointer to a key here. If you see up near the second line of stuff, or actually look further down, there's some random data. What this pointer is pointing to is the key offset. The way that this file format works, is that the signature file that's encrypted also contains an encryption key that's combined with a hard-coded key that's encoded in the code. They're just basically XORed together. That's a little bit more complicated, but they're simply combined. And then the resulting stuff is sent to OpenSSL to do the decryption. So it's a fairly straightforward process. So all we need to do is replicate the code that's in package payload extract, and we've got a decryption utility. So here's an example of us building the code and that sort of stuff. So doing this, we can develop a standalone tool. And assuming that my VMware stuff is all booted and stuff, we're going to go and do that. Oops, not that. Sorry, I meant to hit Alt-Enter to make VMware go to full screen, but I hit the wrong key. Now, sometimes when you do this, you just have a hard time finding the on button. Okay, I typed in root. That's not root. Root has 2 O's. Unfortunately, we set this image up and we couldn't get it to suspend correctly, so it's going to sit there. How many people here use VMware? Okay. Oh, I'm sorry. Come on. I unfortunately did not assign enough memory to this, so it's sitting there swapping away like a dervish. So in this directory, we have 3 files. Reveal, that's the program that we wrote. That does the decryption. And what it takes is 2 inputs. When you get an update, in the case of Tipping Point, when you get an update, you get actually 2 files. You get the actual signature file, which is sig underscore 2.2.0, blah, blah, blah. And then you get another file, in this case it's signer.pem, which is just your typical OpenSSL certificate. So the key within the sig file is combined with the key in the code to then use the certificate to decrypt the file. So that's what we're going to do. We're going to type in reveal. signer.pem, foo.tar. And it's a tar format. So we tar xvf, foo.tar, and then we get the files in there. And one, of course, you'll notice in the middle there is signatures.xml. So we go to the directory, and there are the files. So let's grep ZDI signature.xml. So then we have all the signatures. We can also vi signatures.xml. How many people here are familiar with Snort? How many people here are familiar with other IDSs and their internal architectures? Okay. So what we see here is what we would find for a lot of products. In this case, most products these days, in the old days, they didn't use XML. And of course, XML is like the one true religion, so all products now ship their stuff in XML. So here's like IP options, record route. Of course, that's a very simple signature. That's the first one in the file. It's a 10 megabyte file, and so there's lots more stuff down below. But we see what we would expect for signatures. It's got signature ID, it's got some tests here, it's got some description text, some links. A lot of these are very similar to Snort, but just broken out if you imagine Snort in XML format. So we can then search for ZDI. Okay, this is a ZDI signature. So this is net backup, BB Java miss, format string vulnerability. So that's interesting information. And this is one that the ZDI got through their program. They worked with the vendor to solve the program and stuff and put protection in their product. So let me go down here, and then we get a lot of the data. So this one doesn't tell us much about the vulnerability. So we see typical format string stuff. So all this is telling us pretty much is it's looking for what we expect for a format string vulnerability, like 9090, which is like NOP/SLED plus like %x%x%x. So, but that's the simple trigger. A lot of these things also have more complicated regex. So the way that tipping point works is it does a simple pattern match first very, very fast, and then more generic, powerful regex expression. So a lot of these signatures, though, have better stuff that give us more specific stuff about the vulnerability. Now, unfortunately for Dave and I, we don't have a subscription to Tipping Point service. So the only files that we have are the ones that we get either when we buy a box from eBay or when we talk to our customers that sometimes have the product that will give us a file to look at. So a lot of these, though, when we go down and look into them, we find that they have stuff when we look at the regexes that can help us more specifically build exploits from them. So that was the issue with the Macintosh. There was a contest earlier this year. It's kind of well known. You guys have probably all heard about it. In CanSec West, where they offered $10,000 to someone who can break into a Macintosh. And so the ZDI program offered the $10,000. It started out with a smaller thing of just saying, you'd win the notebook. That's what the CanSec West organizers started with. And then ZDI piled in and said, hey, let's make it more interesting. Let's put our money where our mouth is. So they offered $10,000. And, of course, someone found the bug. They had broken into QuickTime for Java. And so then there was these rumors that the exploit had been sniffed. The rumors turned out to be false because the person who claimed them said he'd sniffed the wireless and got the exploit, but the test actually had no wireless connection, it was wired, so it probably was false. But anyway, so ZDI said, okay, since there's a risk that the exploit's out there, let's publish the zero-day rule. So we know of two different groups that then took the rule file from that, decrypted it, and then based exploits upon what they saw within the signature for the exploit. So even though the exploit hadn't leaked out the way that the person had claimed it did actually leak out through the ZDI process. So that's really the point of the talk, is that it's a two-edged sword. Is you're shipping out your protection, And then yet you're also helping people. You're also helping the hackers. It's a risk that you're protecting the hackers. I mean, that you're notifying the hackers. This is another signature. And so that's what happens. So the signature actually contained these strings, QT pointer ref and get size. And when you Google that code, when you Google those strings from the signature, you get links, all sorts of Google links to real source code for doing normal stuff. And when you look at that, you say, well, as a hacker, I can do these tests, and I can probably see how I can disrupt it. The reason it worked was that Java was a front-end from back-end QuickTime utilities. The back-end QuickTime stuff didn't have the robust buffer checking that Java does, but Java passing things on through overflowed the buffer. So one thing, we're kind of beating up on Tipping Point here because they have the very well-known controversial ZDI program. But what we showed here applies to every other product. Is every single product we've looked at on the market, every other IPS, it's fairly straightforward. So the process of I can find some strings, I can look at where the strings are in the code that tell me it's decrypting, I can find the decryption function, and I can trace through it and replicate it in my own code. So that applies to every other vendor. Tipping Point's responded fairly well to this. When we notified them, they immediately pulled back the 0-day from their updates. So all the 0-day that was in danger of being disclosed, they immediately pulled that back. And then they restructured the program to have stronger NDAs with people so that the typical customer doesn't actually have the 0-day stuff, but the ones that they got NDAs that they can trust. For example, the customers won't give us those files ourselves, so we can't decrypt them. That's who they give the 0-day stuff to. So that was actually very quick in response. They've also, we haven't had a chance to, of course, verify this, but they've made some changes so our techniques no longer work. Of course, our techniques still work from older equipment. So if you've got all these older files, our tool will decrypt them. The changes they made also were slight changes. And here's the big issue, is that to really protect this stuff, you need to be really designing the system from the ground up for protection. You need to make it hard for us to pull out the hard drive from the system and get the image. So when you look at your cell phone, when I try to break into cell phones like this, the cell phone has a lot of protection that I simply can't pull out the flash chip and change it and stuff and tweak it and read from it because they don't want me reverse engineering the cell phone. So that's the sort of stuff you need to add. Another thing we need to add is pre-compiling the signatures. So PCRE contains functions that say take a regular expression and then convert it into a binary blob that the engine actually uses to evaluate the regular expression. So if a vendor, instead of shipping those regex, were to ship the compiled PCRE, it would make our life a lot tougher. We can see the signature file, but now we always see these maybe base64 encoded blobs, and they don't mean anything to us. We have to then take that signature and then reverse engineer it back to what the original regular expression was. So PCRE's compiler tools only go one way. They compile the regular expression, but it's hard to extract it. Now, of course, then we might write a tool that would take any PCRE regular expression and compile back to the normal regex. But if they make some minor changes to the PCRE code, it would totally defeat that tool. So that's what companies need to think of. If they've got dangerous content within their security products, they need to think through, I need to defend them the same way that maybe DRM companies defend their DRM. Another suggestion is the way that viruses protect themselves. A lot of viruses these days do not want the antivirus companies reverse engineering how the virus works. So what the virus writers do is they put lots of code around the virus to protect it. It mutates itself. It checks to see if it's running under a debugger. It has specific code sequences that confuses the IDA Pro disassembler, because they know what their opponents are doing. So you should put those techniques in the code as well. So in this case, it took us about 5 days to do the reverse engineering from beginning to end. 5 days worth of work, plus 2 days of just going off for coffee while IDA Pro sat there and turned away. So with adding these techniques, it could take us 6 months to try to figure that out, or even a year. We'd still be able to do it. This is not like a vulnerability you can fix, but yet you can make our life a lot tougher. And then us lazy hackers can't just spend 5 days and get a nice 0-day stream. We'd have to do a lot more work, and we are much less likely to do that. Any questions on this part of the presentation? Question? The VxWorks image. Tipping Point, like a lot of routers and other IPS products, runs on VxWorks. And just like your mobile phone, by the way, it's one big image. So it's not like a file system with lots of little programs. It's one huge image. So that's what we disassembled. Other questions? Cool. So that was mostly Dave's work, actually. This part was mostly my work. So this next part is another lazy attacker's guide to attacking stuff. We all know that we can sniff stuff off the local Wi-Fi network. So Black Hat has a public Wi-Fi network. And we all know that we can just open our laptop, sniff it, and we can discover all sorts of wonderful stuff. But what we're lacking is tools that put that together and make it easy for us. So what we developed was a tool that is specifically targeted at Web 2.0. Most of the applications out there, like MyBook, MySpace, Facebook, Gmail, Yahoo Mail, Hotmail, they all work with a common architecture. They use SSL or some other encryption to encrypt the password when you log on, so that a person sniffing the wire cannot gain the password. But they generate a unique session key, and then that session key is what's used from that point on for the session. So all I have to do is sniff the wire, find that session key, and then I can then hijack other people's connections. There's two ways you can do that. A lot of these Web 2.0 applications put the session key in the URL. So you'll see a URL like something.com, blah, 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 ID equals this long number. Other companies use them in the cookies. URLs are pretty easy to hijack because I can just copy the URL from a sniffer and just type it into my browser, and then I've hijacked the connection. Cookies are a little bit harder. So let's look at cookies. The way cookies work is they contain the state of the information. HTTP is kind of an odd protocol that it's stateless. I make individual requests that are self-contained. So there's no memory between one request to the next request, what's going on in the system. So this was fixed by Netscape with cookies. What happens is the server sends the browser some information, say, hey, when you give me your next request, please add this little bit of information onto it. So for example, I don't know who your username is from one browser click to the next. I'll send up the username as a cookie. So, hey, Mr. Browser, next time you click on a web page, please send me, as a cookie, the username. That's one sample. Cookies have a number of attributes. They're just arbitrary name-value pairs. But they also are assigned to a path. So as you're browsing through a website, they're assigned not just to any part of the website, but to subsections of the website. So, for example, CGI bin programs might want cookies, so you might assign a cookie for CGI bin that wouldn't be added to requests to other parts of the website. There's also the domain. A lot of cookies are set to often like Google.com will apply to any of the websites in Google.com, or it might just be mail.google.com that a cookie is assigned to. They're also given expiration dates. So the server tells the browser how long to keep it for. Persistent cookies it can keep for a day, a year, 10 years, whatever. The non-persistent cookies, the ephemeral cookies, are just given for that session. As soon as you close the browser, all those cookies are gone. So here's an example of a packet capture of an HTTP header. Yeah, up above is post, and there's a URL. There's all the normal stuff you'd see in a header, and I've highlighted the cookie information. And so this is typical. This is from Gmail. And it has lots of information that it wants to know about me, and it just tells me, hey, repeat this information. Some of these fields are the logon session IDs. And that's sent by this one was sent by the client to the server. The server then sends back other set cookie commands saying, hey, here's some more cookie information that when you make requests, please add to your requests. So here's how I can clone your browser. What I'll do is I'll run a sniffer that captures all the URLs and the cookies. I can do this manually just by copying and pasting and stuff, I can use like the browser import feature in like Mozilla to import cookies. So I can do it kind of manually. It's kind of a pain. But I can also run some code that does it. Run one bit of code that sniffs the network and finds all the cookies and URLs. Then write a proxy server that will then overwrite all the cookies. So that when I log into Gmail, the browser sends the cookies it thinks it has already, but the proxy says, no, I've got some new cookies for you. So if I sniffed your Gmail connection and got all your cookies and attached them to my Gmail session, I now become you. I clone you. And you can clone yourself. Just open up 2 browser windows with Gmail, and you can see you can run 2 browser windows at the same time. And there's no way for the server to really know that you're running 2 browser windows with Gmail, or that I'm running one browser window and you're running another one. It's especially if we're behind the same Black Hat network access point. We have the same IP address as far as the server is concerned. So you can think of it like with snort rules. So a lot of us, everyone raised their hand about snort. So here's some snort rules that can find cookies. So you dump them to a file, then you can write a little squid proxy that reads that file and applies those cookies, that data. So this is the mess of what we're saying, is if you're a lazy hacker and you don't want to go through the work, just write a few little tools, and you can do this. The big message about this is that you have like Tim O'Reilly talking about Web 2.0 and how it's going to change the face of the Internet. But Web 2.0 hasn't solved this problem that we've known about for 30 years about sniffing traffic. Every hacker knows that one of the first things they do when they break into a corporation is run a sniffer to get some passwords off the wire and other interesting things off the local network wire. So all these Web 2.0 application vendors like Google Mail, Yahoo, Hotmail, MySpace, Facebook, there's a ton of them, they all have ignored that. So they are all have these applications for you that have just ignored the fact that people can sniff it. So the upshot is any time that you go to a website that asks for a login name and a password and then forwards you to an unencrypted connection, that's a connection that someone like me, or any of you, by the way, I'm putting my tools on our website. Any of us can then just hijack. So Web 2.0 is now fundamentally broken. The same is to be thought of the Wi-Fi access points. Is like the Black Hat access point we have here today is open. You can actually create access points that are more secure. So there are options in like WPA that we can create sessions that are encrypted on a one-on-one basis. So you can hack up a Wi-Fi access point with a radius server that always says, yes, that person's allowed. So no matter what username or password you enter in, you're automatically allowed. So they're not really authenticating you, but they're giving you an encrypted connection to the access point. So there are ways of setting up public access points that anyone can log into, yet which will be encrypted with WPA. So that's a big thing. You have cities these days in the United States. I think Ohio or some state just recently announced is like doing a statewide rollout of public Wi-Fi. And they're rolling out public Wi-Fi unencrypted to their citizens. And this is a huge problem. So now, the government, they said it's okay to have public Wi-Fi that's unencrypted, so therefore I must be safe. And of course, the government is wrong. So here's my tool that I've written. I wanted to make it a little bit easier to have like a nice little self-installing thing, but unfortunately, I'm not going to have that. So I've got 2 tools, Hamster and Ferret. Hamster is the proxy server that reads cookies from a file. Ferret is this tool I wrote a while back that writes cookies to a file. So here's how you'd run it. You would go to the command line and run Ferret. You'd have to figure out which adapter you're sniffing. And then dump all the cookies to a file. Then you have to configure your web browser to go through the proxy. So you go through your standard configuration to say go through a proxy. Because a proxy server, the Hamster proxy server, is going to overwrite your cookies for you. So Ferret saves the cookies, Hamster reads the cookies. This is an example of the file that's produced. So Ferret's going along and producing a file that looks like this. It's pretty simple. It just includes URL information and or cookie information. One of the key things is that it has to save the state per IP address. So there's 100 people here on the Wi-Fi access point. I can only clone one person at a time. I was talking last night with Adam Shostak, and he mentioned cookies are valid for years. Google had this issue a while back where they're just making their cookies never expire, essentially. And so people didn't like that, so now Google agreed to allow them to expire after 2 years. But I haven't had a chance to test this out about how long I can actually have a capture file, like a sniffer capture file, and then come back to it a month later. But in theory, a lot of websites should have this, that I can come back a month later and then hijack that account. Which means you can sniff the wireless network right now at Black Hat, then go home, download the Hamster utility and Ferret utility, process the capture file, run it through Hamster, and then hijack people's accounts that were logged in today. So that's why I actually plan on testing. So when you run Hamster, it's a proxy server. You take your browser, it goes to the proxy server, and you type in the URL Hamster. It's a special coded thing in the thing. What it will give you is a list of IP addresses that it's found. So I can click on any one of those IP addresses, then clone that session. When I clone the session, I'm now that person as far as the websites are concerned. So I list the URLs that I found. The reason I have to list the URLs is the URLs themselves often contain unique strings that I need to know. I can't access the website unless I know that unique identifier. I can also, in Hamster, click on what the cookie information is. There's some interesting things you'll find here. For example, favicon.ico. When I read the cookie information on the wire, I saw it being sent with that request. However, the cookie probably isn't assigned to that file. It's probably just assigned to the root directory. So that's the problem with this tool is when you run something, you gain access to an account, you've only got actually part of the cookie information because not all the cookies are being sent in the right location. And we'll see that when I do the demo. So oftentimes, I don't even need the URLs, though. I can just click like on mail.google.com/mail. So if I've got your Google account cookies, I can just type in the URL of where I want to go without having to click on it. So here's, by the way, why the program sucks. There's no install program, so you got to do all this installation process manually. It screws up your browser. So when you use your browser for this, you get all sorts of strange cookies, and it kind of screws it all up. So I'm using Internet Explorer in my demo because I use Mozilla as my main browser. I don't want to screw up my main browser, so I use a different browser. It crashes or hangs sometimes, so when I do the demo, I'll probably have to restart it. And you actually saw earlier in the previous thing that the program crashed while it was running in the background. For some reason, sometimes I can't read from the text font to restart both processes. Another reason why it sucks is that tracking the URLs are confusing. What I've found is, while I know in theory that I can just copy the URLs and the cookies and go to those sites, in practice I get all sorts of crappy URLs, and I have to find which one it is I'm supposed to click on. So I need to write some software that goes through and says, okay, ignore the GIFs and the images. For certain websites that I know about, like Yahoo, reconstruct the proper URL that's at the top of the Yahoo mail tree. Even though I don't see that one go across the wire because they logged on before I started, I can reconstruct it for what I am seeing going across the wire. So I need to add that sort of stuff. As I mentioned, the cookies are in the wrong place sometimes. So I've seen in a subdirectory a cookie being used, but I'm not sure that it's supposed to be used for any access to a higher level directory. And that's a common problem. It doesn't support SSL. As I mentioned again, it needs an install program. I mentioned this twice because from where this tool is, we can use it because we're techies that like to use command line programs and stuff. But if we want to really make a nice, easy to use version, it needs to have an install program. So now let's do a demo, and let's see what we can do. So I had Ferret running during the demo, and I had Hamster running. Ferret crashed, so I'm not getting any new cookie information, but I saw these websites while that's what Ferret found while I was doing the first part of the presentation. So, by the way, I hope I'm not outing anybody, because that tends to happen during these presentations. So these are just the better seeing over there, the URLs that it found that people were surfing. So I'm hoping to find one that had like Google Mail. Okay, so this guy here looks like he was using Google Mail. So what I've done here is by clicking on this, each time I clicked, I cloned that person. So I reset the proxy settings so I'm that person, so all their cookies. So when I click here, these are the cookies that I have. But when I click, who's that person? Was that one? When I click here, these are the cookies that I have. So each time I click, I change personalities. So let's type in mail.google.com/mail. By the way, another thing why my proxy server sucks. I don't really want to out anybody, so I should have had my finger over that minimize button before I did that. So what happens at that point, I'm not seeing what he's typing. Like if he's composing a message, I'm not seeing that. If he posts a message, I'm not seeing that in the proxy. What I have is just an access as if he had a second window open, which means I can send email from his account, I can reset some of his settings, I can go through and click one by one all of his email, and I can not change the password. Every application I've found, apparently Facebook doesn't. You can actually change their password without doing this. But almost every application in Web 2.0, they force you to re-enter your password before they allow you to change it. So I can't change their password. And I can't sniff their password because that's going over the SSL part. But I don't need their passwords. I don't care about the passwords. I've got the cookie information. So, any questions?
Now, you have the option at Google Mail to make everything go across HTTPS. Will you see anything?
Right. That's a good question. Google Mail has an option that you can configure to go over HTTPS all the time. So that's a good thing. Unfortunately, Google Mail doesn't have enough resources now if everyone started doing that to actually keep up with the load. But that's an option for Google Mail. Hotmail and Yahoo Mail don't have those options, nor do the vast swath of Web 2.0 stuff. Google's actually kind of the leader in Web 2.0, so that's why they probably have the HTTPS option. So if you use Google Mail, turn on the HTTPS options. Question?
What happens to the person who decides to use the hijack?
Yes, because they're probably on their email right now. And they don't know that I'm there. This is a big thing, is firewalls can't stop this, antivirus can't stop it, an intrusion detection system that the company is running on their side can't stop this. There's nothing going on that's abnormal. I'm on my own connection. You might be able to write some sort of signature say, hey, from my own IP address, if I sniff someone else accessing the same cookies as me, maybe you can trigger something. But while I am using in my sample the Black Hat network to do that, I can actually go through my phone. I can go through other networks as well. If I do that, the back-end server might say, hey, I'm getting the same guy for 2 different IP addresses. But most applications actually work that way. They assume that you're on the road with your notebook and also logged on at home at the same time, and they don't want to screw up your sessions. So they allow you to come in from 2 different IP addresses. I have not found a way to do that. In general, there probably isn't a way because... Pardon me? Oh, his question was, is there a way to block the other person from accessing their account? In all the applications I've seen, I can't find a way to do that. I can change some of your settings and screw things up. I can add a signature for Google Mail to say, hey, I love sheep, and or something. So you can play with them and toy with them a bit. You can change the color scheme, and you can do all sorts of stuff. So imagine this, they call up Google and say, someone's like broken into either your servers or my machine, and actually you've done neither. And of course you can probably do stuff like, do more stuff after that point, like JavaScript, injection, and other stuff to actually break into either the server or their machine. But that's not really the point. Other questions?
Can you force expiration for cookies?
No. Well, yes and no. The cookies that I'm getting from the server in my own proxy, I can reset the expiration, which actually probably be a good feature to keep them longer. But I can't force those cookies to expire on their browser because it was sent by that server to their browser. I'm not really interacting at all with that communication. The question was, I don't know if I repeat it, was whether you can force the cookies to expire. Question in the back. Right. The question was, the comment was pointing out that there's a cookie timeout and a session timeout. So the server sends me and it works both ways, by the way. The server sends me a session ID. That session ID is some piece of information remembered on the server. Even though the cookie says keep repeating that cookie for the next 2 years, the server might say, yeah, but after a week, I'm just going to ignore it. It's an outdated session ID. Oftentimes we're seeing the reverse, is the server sends you a session ID, and the cookie says timeout after a week. But actually that session ID is some special encrypted information that will actually last forever. So even though it's in theory timed out from a cookie perspective, it still works on the server. And that's actually a big thing that happens. A lot of these Web 2.0 applications have a sign-out feature. And what the sign-out feature does when you click on it is it erases the cookies from your browser. And that's how you signed out. But yet, when you replay those cookies anyway in my proxy, they still work. I tried that 5 minutes before this presentation, because I thought I forgot I had to do sign out as a protection thing, and it didn't work on Gmail. So I signed out on Gmail, but I was still accessing it on my other system, and it worked just fine. Other questions? It'll still have the cookie, but the session ID will no longer be valid. The session ID is in the cookie. The question is whether it uses a cookie and a session ID embedded in the URL, and the session ID expires. Right. If that session ID becomes invalid, then I can send cookies to my heart's content, and I still not going to be able to access that resource. We have 10 minutes left. Actually, I'm kind of done. A question in the back. Is there anything a user can do to invalidate the cookies that I've stolen? And the answer is I can't find a way. I don't think there is a way. So Dave Maynard is actually kind of paranoid about me because we were in a coffee shop and he had Gmail open and he didn't realize that this Wi-Fi automatically connected. And so I saw all this stuff go by. And so he's paranoid now that I can log on to his Gmail anytime. And you can't change it. By the way, most of these things, you can change your passwords to your heart's content, but it still gives you back the same session IDs and cookies. So that's not a protection mechanism either. So he's just waiting for me to start playing with him in his email. Question in the back. The question is, when you sign out from Gmail, does it reset your cookies? And the answer is yes. It does reset your cookies. It tells your browser, please forget all about those cookies. But those cookies are still valid. I've got those cookies, and they still work. So you can sign out, you can change your password, and I can still often break in. It depends upon from company to company. So Yahoo Mail might be different than Hotmail, might be different than Google Mail. Question? The question is when I'll be adding new postings to our website. I want to fix a couple more bugs like the one you saw when Ferret crashed. I want to fix a couple more bugs, and we'll be posting either today or tomorrow to our website. Probably today. But still, they're kind of irritating to use. So maybe in a couple more weeks I'll have better install programs for it. Yes. Yeah, the question is, can I import PCAP files? Ferret has the ability to import a PCAP file. Just ferret-r in the file. That will then dump the cookies, and then you can use Hamster. So you can go to a router, use your libpcap utilities, and then import them all the way through. So I think we're about done. Thank you very much.